start. So this is the fence problem, right? So take a look at it and see the fence. So can you see what we've got here? This is X. This right here is Y. Do we care about any of the other stuff? The height of the plane above the ground? No, doesn't matter at all, right? All we care about is that. So we have an initial velocity, we have an angle. We know that this X is 1440 meters, and we're just looking for that Y. So this is even easier because, well, no, we know the mountain's height, right?
Yeah.
What is the mountain's height? So 4,000, so is this 450 meters?
Yeah.
Okay, so we have X, we have Y, we have V0 there. Now, this is one of those fun problems because what do you notice about the angle? Yes, 37 degrees. This is a 3, 4, 5 triangle, right? So you can figure out certain things, like you can play with that or remember angles. So the way we're going to use that is when we crack this vector, we can do it without using a calculator. Because this is a 3, 4, 5 triangle, which means the Vx goes like this, the Vy goes like that. If this is 150, what is 5 times what is 150? Yeah, 5 times 30. So if this is a 3, 4, 5, then this is 4 times 30. Sorry, I should be doing this. Right? 5 times 30. So this is 4 times 30, and this is 3 times 30. So we know that this is 120 meters per second, and this is 90 meters per second. Right? And that makes life easier. So now all we have to do is pick a dimension and go with it. So I'm going to choose, let me see, I'm going to start with the X dimension, and I'm going to look at my two equations. I'm going to say delta X equals Vxt, and I'm going to say delta Y equals Vyt plus 1/2 a t squared. So I'm going to get my t from my X. Oops. So if I shrink this back down again to this, now I can go back to here, and I can say delta X is Vxt, so t is equal to delta X over Vx. So that's going to be 1,440 meters divided by 120 meters per second. Cross out the zeros, and I get 12 seconds. Everybody see how I did that? Questions? Okay, next, if there's no questions, I see none, okay. Then I say delta Y is equal to Vyt plus 1/2 a t squared. So all I'm doing now is calculating Y and plug it in. Then I'm going to compare that to the 450 meters. Okay, so we take, this is going to be 90 meters per second times 12 seconds plus, oops, sorry, just kidding. And of course, doesn't let me do that, so I have to erase that. Minus, and I'm just going to do this with 5 to make my life easier, and that's 12 squared. All right, so this becomes 90 times 12 is 1080, minus 5 times 12 squared, which is 144, so that's like 720 or something. Right, and then 180 minus 720 is 360. 360 meters. Mwah, mwah, mwah. Sorry. That's supposed to be skull and crossbones. That's really bad. I'm not an artist, so we're gonna get rid of that. Anyways, questions? The plane did not survive, and thus you get this really scary movie from the 70s where all these people eat other people because they're dead in the mountains. Yes?
How do you know that they
Okay, so what did we just calculate? The distance vertically. So this plane going at that velocity, at this angle, in 1,440 meters, is going to be at an altitude of 360 meters. How high is the mountain? 450. Game over.